Hello everyone, today we're going to be looking at how to construct a line of root 2. So this can also be used for the likes of root 5 and root 10. And then after, we're going to look at how to construct a line of root 3 and root 8 so they can be the same. So when you create a line of root 2, what we're actually doing is we're going to construct a right angle triangle. So that's for both the root 2 and the root 3. However, for root 2, root 5 and root 10, what we're going to be doing is we're going to be using the hypotenuse. However, when we look at root 3 and root 8, we're going to be using the adjacent side to construct our line. So with that, we'll get started. So what they'll always tell you in the exam is that you can construct it using only a compass and a straight edge. So what that means is we have a math set here, or whatever one you have will do, but all you really need is this, a compass, and this, a straight edge. So the first thing you want to do is you're going to use your straight edge to draw a line segment AM. So we'll just get out a pencil. And just any line will do, like that. So this is my, let's say, A, and here is my M. So straight away what you're going to want to do is you're going to get your compass, and it doesn't matter what length you want, but obviously you want it to fit the line we have. And what we need to do is we need to create equal spaces between like 0, 1 and 2, and we're going to name these, so we already have A, and then we're going to create a B and C. So for example, so make sure that the first one is kind of like at least a third, or at the most a third really. So that's 1, and without adjusting the compass, so make sure that's kind of the same length, we'll do another one, 2, and then another one, 3. So what I've done is I put the compass here, and then I've moved on to here, this point, and this point. And each point I put the compass, I'm going to name it B and C. And these are essentially, so let's say A is basically my 0, B is basically my 1 unit, and C is basically my 2 units. So now using your calculator, using your compass, what we're going to want to do is we're going to have a bisector, or the perpendicular bisector of AC. So what you're going to want to do is get your compass, and you'll want a size that's between B and C. So you don't want it going over C, and you don't want to be less than B. So you want it, let's say, halfway between B and C. So like unit 1.5 almost. What you're going to do is you're just going to draw, or it has to be kind of a semicircle, like so, and without adjusting the compass, you're going to want to do it again. It's like that. So the perpendicular bisector basically means that we have a 90-degree angle. So I'm going to get out my straight edge again, so my ruler, and just mark off, so from here all the way to there. So I'm just going to use a red pen to make it a bit easier on the lines I've drawn. So AC is really the line that's most important. That's point 1. Now what I'm after doing now is I'm after creating this line that's the perpendicular bisector between A and C. So it's halfway, let's say, between the two. And what that does is it cuts it here at a 90-degree angle. And we do this because we want to create basically a right angle triangle. So what we can see now is we can join, let's say, these 2 points, and we'll call them, let's say, D here and E here. Now, what you want to do is you want to mark a point, we'll call it F, that is the same length from AB to BF, okay? So D is just the line, and F, so we can just, over here what I'm going to do is the length AB is equal to the length AF. And we know that the length AB is 1 unit. Because we used our compass, so let's say when we used our compass we drew this line here, so that was 1 unit like I said, and our C was basically our 2 units because we moved the compass once and twice. So now what we're saying is we have a length between A to B of 1 and a length from B to F of 1. So now what we can do is we can draw our line AF. And using Pythagoras' theorem, so we know that A squared plus B squared equals C squared. So we have the, let's say, the opposite, the adjacent, and the hypotenuse. So generally we use these when we're dealing with sine, cos, and tans, or the trig functions. But what we're going to do is we're going to say, well, the opposite is 1 squared. The adjacent is 1 squared. So that's, let's say, the length AB squared plus the length AF squared equals the length AF squared. Okay, so equals C squared. So we can now see is that 2 equals AF squared. And the length AF, so whatever we do to get rid of the squared is we square root both sides. So we put a square root over that, and that basically cancels this out, and we have the length AF is equal to root 2. And that's what we're trying to construct. So we're going to use A as the center, okay, and F as our so what we're going to do is we're going to get back out our compass, and we're going to start at A, so that's going to be our starting point. We're then going to get the length AF, so you can see it there, and what I'm going to do is I'm going to drag a nice line like that. So right on the, so I'm going to call this the x-axis. It isn't, but it's basically the line we drew initially. So what I've now done is you can see this line. I'm just going to, with just kind of dotted lines. So that's the line I drew on the compass, which is the length root 2. So I'm going to just do a line like so. And it doesn't matter what we call this, but we've gone from A to F, so the next letter we have in the alphabet is G. So we're going to call this G. So now we know that A to B, which is here, is 1 unit. So this G here, because we've measured A to F, which is root 2, that G is equal to root 2. And that's how you construct your line of root 2. And what's really important, and what I've showed in the video already, is that this Pythagoras theorem is very important to actually show that's what you're using, because it's a proof. So just by stating I'm using Pythagoras theorem and then giving the equation like this, then you're showing the examiner that that's what you're using. So thank you for watching this video, and I'll see you when we look at constructing the root tree.